Well, we've talked about SOHCAHTOA and finding the values of these functions if we have an angle that is acute. We've started from a right triangle, and the acute angles in a right triangle are always less than 90 degrees, right? The two other angles in a right triangle. What if the angle is not an acute angle? So let's play this. What if it's a quadrant 2 angle? What if that happens? What if this is my angle theta? Or what if it's a quadrant 3 angle? What if it's down here somewhere? What if this is my angle theta? Or what if it's a quadrant 4 angle? What if it's down here in quadrant 4? How do we play that then? Because we don't really have, for one thing, you can't make, if this is the interior angle, then we can't make a right triangle out of this. Yeah, we can make this, but that's no longer in the interior of the triangle. And so there are a few other concerns to take note of here if the angle is not acute. All right? The key to working with angles in other quadrants, the key to working with angles in other quadrants. If everything's in quadrant 1, things don't get really all that difficult, but very often they do. We know that it's not unusual for a walkway to be at a 150-degree angle. That's entirely plausible to have a sidewalk have an angle in it that's 150 degrees or whatever. Or you might have a turn in a road and that angle might be measured to be 255 degrees or some such value. And so these kinds of numbers, these kinds of angles do arise in practice, and we need to know how to handle them. If we restrict ourselves only to acute angles in the first quadrant, then we've left off a lot of the power and a lot of the applicability of trigonometry to the kinds of problems that you're going to encounter. And so, what if the angle is not acute? Number one, let's assume everything is in standard position. Then we introduce a huge notion. This is a biggie. This is a big, big idea. It's called a reference angle. A reference angle. Now, there are a couple standard, just baseline pieces of information about reference angle. Number one, reference angle applies only to, and here's the phrase I'm going to use, non-quadrantal angles. Is it clear what that means? It needs to not be a quadrantal angle. That is to say, I am not talking about that angle. If the angle measures 90, a 90-degree angle does not have a reference angle. 180 degrees does not have a reference angle. 0 degrees does not. 360 degrees, 270 degrees. Quadrantal angles do not have a reference angle. Reference angle only applies to non-quadrantal angles. If it's not a quadrantal angle, it doesn't matter what the other properties are. If it's not a quadrantal angle, we're not talking about reference angles in the first place. So reference angles apply only to non-quadrantal angles. A quadrantal angle does not have a reference angle. If you cannot smell a multiple choice question coming, you need to give another thought. That is an easy multiple choice question to write out. Is I would say, suppose theta is equal to 180 degrees. What is theta reference angle? And one of the choices needs to be none of these because it doesn't have one. All right, so applies only to non-quadrantal angles. The next piece of a reference angle. First off, if the angle we're talking about is theta, if it is a quadrantal angle, it does have a reference angle. So this is theta. Theta subscript r. This is what I'm going to call theta reference. Theta reference. If I call my angle theta, it's theta reference. If the angle is x, it's x reference. If it's alpha, it's alpha reference. If it's phi, it's phi reference. So whatever symbol you use for your angle, theta reference is that symbol with the subscript r. This means the reference angle. So that's the symbol, that is the notation that I will use consistently every stinking time we use a reference angle. I will indicate it by the subscript capital R. Theta reference is the reference angle for theta. And now the other piece is this. Theta reference is always, always, always. This is the definition, part of the definition of theta reference. Theta reference is an acute angle. Theta reference is an acute angle. No matter what theta is, theta can be anything on God's green earth, but theta reference is an acute angle. No matter what value theta we're starting with, if it is non-quadrantal, then it has a reference angle, and that reference angle is acute. It's between 0 degrees and 90 degrees. Okay, so now let's take a look at the particulars. Now, describing the reference angle precisely is a bit challenging. To write out in words, well, the reference angle is, it's a little bit like riding a bicycle. Reference angle is like riding a bicycle. To write out precisely in words exactly everything that goes into riding a bicycle takes forever. But to just show somebody is easy. I could just you can show somebody how to ride a bicycle easily. Just get on it and go. Showing someone what a reference angle is, it's obvious, it's easy, it's straightforward, you see what's going on. To write out the details is going to take a while. So I'm not going to write out all the minute details. And you don't need to be able to write out all the minute details. But you stinking better know how to use reference angles, because they're not going to go away. Between now and Christmas, they're going to be all over the place. And so, I will consider each of the 4 quadrants in turn. All right? In quadrant 1, if this is theta, if theta is in quadrant 1, theta and theta reference are equal. In quadrant 1, theta and theta reference are equal. So, if theta is 72 degrees, what is theta reference? If theta is 72, if theta is 72 degrees, theta reference is 72 degrees. If theta is 12 degrees, theta reference is 12 degrees. In quadrant 1, theta and theta reference are the same angle. In quadrant 1, theta is equal to theta reference. So if theta is 42 degrees, theta reference is 42 degrees. All right? Quadrant 2. There's theta. Now, this is a description that you do not need to write down. I'm not going to write it down. But this is a description of the reference angle. Number 1. The reference angle always has vertex at the origin. Always has vertex at the origin. It is formed by, the reference angle is formed by the terminal side of theta and the x-axis. It's an acute angle. Vertex at the origin is formed by the terminal side of theta and the x-axis. Now, of all that, the biggest piece is this. Well, it's always acute. The biggest piece is this. Theta reference, never, and I mean never. When students mess up their reference angle, the single most common mistake students make when you mess up the reference angle, the most common mistake is they have the reference angle touching the y-axis. The reference angle does not lie against the y-axis. The reference angle does not lie against the y-axis. The reference angle lies against the x-axis. The reference angle lies against the x-axis, and it must be acute. With this angle, I want the acute angle that is formed by the terminal side of theta and the x-axis. Well, it could be this. No, that's not acute. That is acute. Always, always, in quadrant 2, theta reference looks like this. In quadrant 2, theta reference looks like this. If theta is 100 degrees, if this is 100, the question is how big is that? It's got to be the rest, because it's got to add up to 180. If this is 100 degrees, then theta reference is 80 degrees. If this is 120 degrees, then theta reference is whatever is the supplement, that is 60 degrees. Notice what I'm doing. I'm taking 180 minus theta. And so if theta is 140 degrees, this must be whatever is needed to add up to 180, so theta reference would be 40 degrees. So given any value of theta in quadrant 2, you should be able to find the reference angle. And vice versa. Suppose you're given the reference, suppose you're given theta reference. You need to be given quadrant 2. Given quadrant 2, and given theta reference is 20. If you know this is 20, then you should know how much theta is. If this is 20, we know the grand total has to be 180. If this is 20, that's got to be 160 degrees. Again, these are degrees. If theta reference is 40 degrees, if theta reference is 40, then this has to be everything else. If theta reference is 40, then theta's got to be 140 degrees. If theta reference is 35 degrees, theta reference is 35 degrees, this has to be whatever adds up, makes it add up to 180. So if theta reference is 35 degrees, theta must be 180 minus 35 degrees is 145 degrees. So given any value of theta reference, if you know the quadrant, given any value of theta reference, then you should be able to find the value of theta. And given any value of theta, you should be able to find the theta reference. All right? Quadrant 3, how does it work in quadrant 3? Suppose this is my angle. Theta reference, in this case, theta reference was here, right? Theta reference lies against, it has the terminal side of theta and the x-axis. The most common error students make is they put theta reference here. Theta reference never ever touches the y-axis. It's like the third rail. Theta reference never ever touches the y-axis. Theta reference never ever touches the y-axis. Theta reference always lies against the x-axis. And so, suppose we're given theta is a quadrant 3 angle. Suppose theta is known to be 200 degrees. Well, if this is 200, then the question is how much did you add to the 180? This is 180 plus a little bit. So if I take my 200, subtract off the 180 that I don't want, that leaves me with the reference angle that I do want. This is theta reference. So in quadrant 3, the reference angle is you take 200, subtract off the 180. Theta reference was 200 minus 180. Theta reference is 20 degrees. What if theta is 240 degrees? That means it's 180 plus a little more. So if this whole thing is 240 degrees, don't worry about the 270, worry about the 180. You need to subtract off the 180 to give this leftover pieces, which is what we're looking for. So 240, subtract off the 180. If theta is 240 degrees, theta reference is 60 degrees because the 180 plus the 60 gives you the 240. And it works also the other way. Now, if you're given the reference angle, you must also be given the quadrant. Because if I tell you the reference angle is 20, you don't know if I'm talking about this picture or this picture or this picture or that picture. So you must also be given the quadrant if you're given the reference angle. So suppose the theta reference, suppose we know we're in quadrant 3, and suppose we know theta reference is 10. Then we know this is 10, so the question is how much is that? It's 180 plus the 10, so theta must then be 190 degrees. What if theta reference is 33 degrees? If theta reference is 33 degrees, this is 180 plus the 33, and 180 plus the 33 degrees is 213 degrees. So given any value of theta reference and the quadrant, you should be able to find theta itself. Given any value of theta, you don't need the quadrant because theta tells you what quadrant you're in. Given any value of theta, you should be able to find the reference angle. And then last, we'll look at quadrant 4. So let's suppose this is theta. It might be 300 degrees or 310 degrees or 340 degrees, between 270 and 360. Theta reference lies against the x-axis and the terminal side of theta. Theta reference never ever touches the y-axis. So theta reference is here. And the same exercise can then happen. If theta is known to be in quadrant 4, we're in quadrant 4 now. If theta is 300, if this is 300, how much more do you need to make 360? Well, theta reference then would be 60. These would be degrees. If theta is given to be 290 degrees, how much more do you need to make 360? Well, if this is 290, then theta reference would have to be, how much do you add 290 to get 360? That would be 70 degrees. And so given any value of theta, you should be able to find theta reference. And just as we've done before, if you're given the quadrant 4, and if you're given theta reference, then you should be able to find the value of theta itself. So working with the reference angle needs to become just a standard benchmark basic. Eventually, one of the things we're going to be doing is solving trigonometric equations, and every stinking trigonometric equation, almost, has some dealing with the reference angle. If you cannot work with reference angles easily, fluidly, straightforwardly, if you cannot work with reference angles, then it's probably fair to say you're not going to have hardly any success solving trigonometric equations, which really is one of the pinnacle notions of the course. So, reference angle applies only to non-quadrantal angles. It must be acute. Non-quadrantal angles must be acute. 180 degrees does not have a reference angle. 270 degrees does not have a reference angle. Non-quadrantal angles have reference angles. It must be an acute angle between 0 degrees and 90 degrees. And it lies against, the reference angle lies against the x-axis and the terminal side. Reference angle never ever touches the y-axis. Reference angle never ever. Reference angle never ever touches the y-axis. And so with that, we should be able to, given the reference angle and the quadrant, you should be able to find theta. Given theta, you don't need to be given the quadrant because theta determines the quadrant. Given any value of theta, you should be able to find the reference angle. So freely going back and forth between theta and theta reference should become automatic for you. In quadrant 1, theta reference is theta. In quadrant 1, theta reference is theta. That makes things easy. In quadrant 2, you have to fiddle-faddle with the 180 degrees, either adding or subtracting, depends upon what process you're doing. In quadrant 3, you need to fiddle-faddle with the 180 degrees, depends on which of the processes you're doing. And in quadrant 4, you need to play with the 360 degrees. You always play with the x-axis value, not the y-axis value. And so x-axis value, you fiddle-faddle with the 360 degrees. Adding or subtracting depends upon which problem you happen to be approaching. So reference angle is an absolute key, fundamental, must understand it. It's bedrock notion for the work we're going to be continuing on with.